Okay, good evening to everyone. My name is Marco Lettere and I work for an Italian company named Dedalus, and I will present to you today what we have done so far with BaseX, using BaseX as our main pervasive tool to develop an architectural framework for service-oriented architectures in healthcare. I'm a computer scientist, officially since 2001. Currently I'm employed at Dedalus as a tech lead and senior software engineer in the R&D department. My background is mostly related to computing, system integration, those kind of things. I like also other stuff like computer graphics, and I play soccer. Maybe the rest or not. Our company is an Italian company, mostly involved in IT for public and private healthcare. We have several sites all over Italy, and we are currently expanding also worldwide. Those are a few countries where we currently are opening sites, or we already have actually. We have a strong focus on standards related to healthcare, IHE, HealthSOAF, and ICOM. I don't know if any of you have already heard about them, but that's it actually. That is our site. Okay, a few words about the context. Everything is based on mainly two pillars, which are HealthSOAF and OMG. You know, both of them are standardization institutions, and mostly the first one is related with healthcare, format, model, messaging, whatever. The second one actually standardizes more or less everything. They two joined together for an initiative named HSSP, which stands for Health Service Specification Program, and what it is, it actually represents a technical specification framework for a bouquet of services that are commonly found in healthcare, especially when we are talking about large-scale enterprises, cross-domain, whatever. Those services are listed here. There is RLAS, which is Resource Repository Service Specification, IXS for Identity Management, there is CTS2 for Code System and Terminology Management, Service Directories, and Clinical Decision Support. What is HealthSOAF? HealthSOAF is actually an Italian project funded by Italian Ministry of Research and Education that aims at analyzing, in-depth studying this specification provided by HL7 and OMG, then deliver a complete implementation of these specifications. Actually, the first one in Italy, and set up a pilot site for demonstrating this implementation, set up and maintain, of course, in the midterm. And then also produce documentation, implementation guidelines, those kind of things that could help other companies to adopt the specification. The site of the project is written here in orange, and the partnership are mainly us and another large company in Italy, Almaviva. Then there is a set of smaller companies like Simple Engineering, and also academical partners like universities. Okay, what is our role in the movie? Actually, we were in charge of implementing and maintaining 3 of these specifications, mostly one for the resource repository, which we use for storing clinical reports and observations, medical prescriptions, workflow documents, and also documents related to accounting and billing. The specification comes with the 2 platform-dependent specification, which is actually, one is based on WSU SCAR, which means all those SOAP, WISTs, and so on, and one based on REST. IXS is a service specification for identity management. So actually, we use it, for example, for storing identities of patients, clinical operators, but also devices, and so on. Identity management here means being able of identifying uniquely an entity across several domain and identification realms. So it has nothing to do with authorization and security in this sense. This specification comes with a WSU star interface specification. And finally, we also had we're in charge of developing the code system and terminology service, which actually aims at managing code systems in the large. So not only a list of name and value pairs, but really a code system viewed as an ontological domain, so the concept domains, value sets, relations among each other, and so on, version, history, whatever. This mainly comes with a REST-based interface. Okay, so the context has been done. Now the interesting part, in the last years we implemented this specification, and the result is this. Okay, it looks messy, no? Yeah, besides talking about SOA and architectures and whatever, at the end the result is always messy. No, okay, we will clear it up. So first a bit of minor technology, not BaseX related. We use an Apache tool server for publishing the service on a public entry point, and an ESB based on Apache synapses for all the orthogonal things like multi-tenancy management, security, and those kind of things. We deploy on a virtual environment, which is actually based on VMs running on OpenStack. This is on everything is managed by us, by the R&D department, so it's not that large, but we try to experiment always with the new technologies for doing stuff. Mainly we use multiple VMs for deploying instances that are different according to code maturity level and functionalities. For example, I will show you here where BaseX actually comes into play. We have different deployments, as I was saying, mainly because we use different functionalities across the versions. For example, the largest difference, the biggest difference between 7.x and 8.0 is one of the things is actually the use of mix updates, which simplifies a lot of the interfaces, as we can see further on. Okay, how is the HSSP kernel implemented? Well, I try to draw instead of to take a picture of a whiteboard, but still it's messy. Okay. Anyway, the blue boxes are XQM modules that implement also the REST-XQ, that have also, sorry, a REST-XQ front end. So mostly we have a SOAP skeleton up there, which is the only entry point we have for all SOAP requests. And actually you can see we get into it IXS and airless SOAP messages. The implementation uses the WSDL repository where we store all the WSDLs and the XSDs and whatever for validating the incoming messages and for choosing the right implementation function to call. The implementation function is then called, and those functions are stored in implementation modules, which are the green ones actually. Mostly they don't have REST-XQ interfaces, but they, for example, use the database mechanism of BaseX, because they are actually the implementation of the CRUD functionality, so creation, removal, update, and so on. Retrieval, update, and deletion of resources. Airless, as we have told before, is also accessible through a REST interface, which is also exposed as a REST-XQ module. And CTS2 also has its own REST-XQ module. Okay, these two dots here, red dot here, just to remind me to tell that actually the first one, the access to the WSDL, was our first proud contribution to BaseX, because I asked Christian to get an XSD function which was not the XSD validation function, which was not returning an exception on the first error, but rather to give the whole set of validation errors that were present in a resource. So then this gave the birth to the XSD -info function. The second thing is the red dot there is where we actually needed the mix update functionality, and it helped us a lot in reducing the code base. We will see this, I suppose. Just a small insight into the SOAP skeleton. As you see, it's a pure REST execute function annotated to accept mostly SOAP kind of messages. So the MIME type is application SOAP XML or text XML, depending on which kind of SOAP version is used. There is a SOAP action header that is used for identifying the operation, and the other things are pretty much easy to understand. I slimmed down the code a lot, of course, but actually what we do is we look up with this validate and resolve function for the WISP, the XSDs, we validate the message, and what we get back is a map of information. The most crucial element in the map is the one keyed with the function string, which is actually the function that then will be called inside the implementation module. One of the most tricky parts inside the implementation, trickier parts inside the implementation, was the translation of an Erlast request query into an X query actually. So this is just a small example that I took out of a test case that we have. It is a complex expression that uses unary operators on top of Boolean values, and then concatenates with an OR with a combined binary expression that in turn again uses the between operator, between two numeric values, and concatenates again inside itself with an AND for a string-based search in a sequence. This is the way that complex query expressions flow into the SOAP skeleton through the Erlast transportation protocol. And this is actually what after the translation steps, which is automatic, gets into the X query eval that then executes the query. Well, it doesn't look very nice. It doesn't look very nice because it's generated code, but actually you can see there are the iteration on the documents, then the for on the documents, and then the assignment of the variables that are used inside the expression. They are mapped to XPaths in an external configuration file. And then the final expression, which is actually this simplification of not true, and the amount, which is the between expression on the amount, which is translated with an M, and the in operator of Erlast, which is translated to an equals on a sequence. Okay. For some kind of scenarios, mostly the scenarios that are update intensive, the documental approach is not very simple to use. This causes our clients in terms of software clients or also developers to have a bit of headache in implementing that. So what we did is we provided an extra layer of REST APIs on top of the HSSP kernel implementation. And those REST APIs are exported, published through BaseX. Here it's very simple again. We have two APIs at the moment. So one for the workflow management and one for the accounting and billing. Those are just acronyms. They were exposed as REST execute skeletons. The functions then call the proper implementation module functions, which just generate the Erlast or access to the HSSP SOAP request that would have been sent to the SOAP skeleton directly otherwise. So here the architecture is rather simple. Then we have developed a front-end server, and mostly using all the technologies that were already mentioned, so in previous talks. We developed that just for demonstrating, especially at one review point of the project, how to use the document and workflow pattern now it's also used by clients actually. So, okay, it was a sort of success story. Here again we have one SQL module which has a REST-XQ front end. It's named front end SQL. It uses a lot of implementation modules. Mostly the most important ones are the three modules: workflow module, patching module, and clinical record module, which are just calling either the APIs or the skeleton according to their needs. This is how it looks mainly. It is a rich internet application which downloads for the first time the main page and then makes all the calls to the front-end SQL modules in Ajax to get this information and to render that. Besides AngularJS, we also use D3JS for implementing the visualization. Last, in the architecture, we have the so-called event manager, which is just a module that helps us in routing complex workflows of requests. It's a sort of decision support for routing requests. This is also implemented in BaseX, and mostly what it does, it operates together with the routing functionality of the ESB. The last SOAP request is sent to the SOAP skeleton for proper management. When the response comes back, here on the left part. When the response comes back, the ESB groups it together with the request and sends it to the EM skeleton SQL module. And then in the implementation, this is a sort of decision support that looks at the request and the response and knows what to do according to some business rules, whether it has to update a workflow or to call an external service for auditing and so on. So it's a rather complex routing strategy that we didn't want to put in the ESB because I personally don't like ESB as a programming model, so I prefer to do it like that. Okay, last but not least, we have developed the X-Test, which is not a service on its own actually, but it's just a tool that enables us to do unit testing. We declare our test campaigns and test cases in declarative XMLs, which have actually also a bit of control structures like environmental variables, grouping, linking, and iteration. What it does, it mostly does the last three steps of the testing process, which are the test execution, the test arbitration, so evaluation if a test was successful or not, and then reporting. It leverages heavily XQuery eval, mostly for the environmental variable expansion, and the arbitration that is based on custom X queries. The send request, of course, which is the core of this testing tool, and validate XSD info and the XSLT for XSD schema and the schematron-based application. This is how, for example, the test campaign looks in light blue. I hope it's visible. In light blue, you see the environment variables that are set. Then you can call test cases by referring or even by writing them expanded. Then we can do for each with an open variable. In this case, for example, subject ID, that it iterates through subjects. And subject is an environmental variable, as you can see there. And also inside here we can refer test cases or write test cases using variable extension. A test case looks mostly like a section for validating the input, which is not present in this case, but a section for writing the request. And this uses actually EXPAND formalism to model the requests. A section for validating the HTTP response, so we can do validation at at HTTP level. For example, we can check that status that we are expecting as HTTP status is correct and so on. And here in this example, it's done with a custom XQ, so we just add this validation rule. And we also have validation on the output, which is in green. And this means really semantic validation. So we validate what comes with as a payload of the response. Here in this example, we use XSD for referring to schemas that validated the request syntactically, and there was also a custom XU that did some semantic validation and cut it away for saving space. Finally, there is also a reporting XQuery module that just generates a HTML page like this that reports the outcome of all the test campaign, of the whole test campaign. It has some resumed stats, and then the outcome of every single test, they are clickable, and you can inspect the XML that was traveling and so on. So there is also one level more of analysis. I asked for a mixed report which contained also errors, but my co-workers were too proud, and they said, no, we have no errors, so only success stocks. Okay, conclusions. We learned about BaseX, let's say, 4 years ago. We were using another tool at the time. And as you can see, we are now using it in for us, it's a sort of Swiss Army knife, and we use it nearly for everything. We have reduced the lines of code written in Java to only BaseX extensions that we write from time to time. That's it. So, according to our experience, it's well, I don't see a better way of working with that much XML that we have in our domain, and that heavily structured XML. We have tried also other solutions, but in my opinion, BaseX contains everything we need for building even that complex architectures. Yeah, well, not everything. For example, we needed an ESB. I was thinking of using BaseX also for that, but maybe it's too early. What are the reasons we like BaseX that much? Well, actually, XQuery 3 and REST-XQ are the main reasons, because they help us a lot in nearly everything. And also the sugar provided by the libraries that come together with BaseX. For example, HTTP library is one of our daily bread libraries. And also we like a lot other things like the validation module and so on. My favorite arguments are mostly that we can keep our code base very small. I think we would make Mansi's life easier with this. No, aren't we? No, actually, the whole implementation of the HSAP kernel can be zipped into a few tens of KBs, not more than that. So this is a result which I'm very proud of. This added to the very small footprint that BaseX has on its own, because actually less than 10 MBs for getting all this is really something that's perfect for a minimalist developer like I am. Small footprint in terms of disk space dependencies, and also simplicity of installation, of course. So besides what you have seen, I also use BaseX every time I'm asked by our company's departments to have training or evangelism. This is a new word that I've learned. For showing off how to work efficiently with XML, because there are, to my surprise, a lot of people that still are very scared about XML. They say, no, it's too overwhelming, it's a lot of work, and then I come with my training sessions, and after 2 hours, everyone wants to switch to XML. So this is a nice result also. Okay, not everything is positive. Let me say, otherwise I would be too happy. But no, actually, after decades of modeling everything in XML, also the healthcare domain, which is known to be a rather slow-moving domain, is starting to move towards JSON. So what we need to do, and this is probably not a concept, just something that we have to do for the future, to analyze whether all we have done so far will still be like it is, and BaseX will still play the main role also in that new challenge, let me say like that. And then we have exactly in these days fighting against a performance issue that is plaguing us, and I don't know exactly where it is, so it's very annoying because it probably depends on the combination of the deployment and the scenario, which is pretty insertion intensive. So we have thousands of documents flowing in during daily working time, so from 8 to 6 o'clock p.m., 8 in the morning, and we are not able to keep in pace with that. And I don't know exactly where. We got a lot of CPU usage boost, and we are investigating. We are investigating and we are experimenting with this helps us, of course, because we are trying to optimize our code and writing better our X queries, try to hitting as much indexing data as possible. And, I'm really looking forward to be here next year and tell you hopefully happy ending stories. Yeah, and also I'm pretty curious to see the effects of the new the index, because I think I was one of the guys hit by the disk space usage. Okay. So, if there are no other questions, but I suppose there will be. But anyway, I'd like to thank the community for giving me this exciting opportunity of talking here, especially Christian for we analyze also the previous steps, not only the execution. Sorry. Here I told you that we have text execution, arbitration, and reporting. In that project, we are studying also techniques for scheduling testing, tests, and generating tests. Okay, so the approach is to have something which can easily be generated. And to my knowledge, having a declared XML model, declarative XML model is the best for being generated. This is why actually we started moving the other way around. And also because actually developing it was not that difficult. We mostly had all of the code there because we knew how to do validation. We knew how to do requests. We just needed this XML syntax, but that's all. Okay? Thank you very much for the attention.